Hi friends, in this class we are going to see about this metamerism. Metamerism is one of the types of structural isomerism, and in the previous sessions we completed chain isomerism, position isomerism, functional isomerism. Now we are going to see the metamerism. What is metamerism or what are metamers? Listen to me. The organic molecules with same molecular formula and same functional group, but differ in the nature of alkyl groups are called as metamers, and the phenomenon is said to be metamerism. So, what are metamers? The organic molecules with same molecular formula and same functional group, but differ in the nature of alkyl groups are called as metamers, and this phenomenon is said to be metamerism. Before going to see the examples of these metamers or metamerism, I would like to discuss about functional groups. Now listen to me. Functional groups are classified into two types. What are the two types? Monovalent functional groups and polyvalent functional groups. What are monovalent functional groups? The functional group whose valency is 1 are said to be monovalent functional groups, whose valency is more than 1 are said to be polyvalent functional groups. Now, for examples for the monovalent functional groups, if you see OH group, hydroxyl group, it can be binded with only one atom or group of atoms, therefore its valency is said to be 1. This is monovalent functional group. Similarly, you take aldehyde group or carboxylic acid group, or you take acid halide or acid chloride group. So these are all said to be monovalent functional groups. Primary amine group NH2 is a cyanide group CN, isocyanide group NC. These are all said to be monovalent functional groups, okay, because of their valency is 1. Then examples for polyvalent functional group. The functional groups whose valency is more than 1 are said to be polyvalent functional groups. Examples if you see for the polyvalent functional group, ether functional group. What is the valency here? 2. So it is said to be a polyvalent functional group. Next you take ketone, C double bond O, whose valency is also 2. So it is a polyvalent functional group. Then you take ester, RC, the C double bond OC, valency is 2. It is said to be polyvalent functional groups. Ethers, ketones, esters if we take, and even we take secondary amines whose valency is 2, tertiary amines whose valency is 3. Apart from these secondary amides we take, for example, primary amide RC double bond O NH2 is a monovalent functional group, but secondary amide group can be written RC double bond O NH, valency is 2, and tertiary amide RC double bond O N, valency is 3. These are all said to be polyvalent functional groups, and these are said to be monovalent functional groups. One very important point here is the molecules which contain monovalent functional groups, they do not exhibit metamerism. The metamerism is exhibited by only the molecules which contain polyvalent functional groups. Means which class of compounds will exhibit metamerism? Metamerism is exhibited by ethers, exhibited by ketones, exhibited by esters, secondary amines, tertiary amines, secondary amides, tertiary amides, etc. They exhibit the metamerism. Now, so what are metamers? The organic molecules with same molecular formula and same functional group, but different in the nature of alkyl groups. When valency is more than 1, you can change the nature of alkyl groups on either sides. When you change the nature of alkyl groups on either sides, they will become what? Metamers. Their molecular formula is same, their functional group is same, but you are changing the nature of alkyl groups on either sides. Because their valency is more than 2, it is possible. So, this is to be metamers. For example, for each class of compound, I will give one example to you. One is ethers, for example. Diethyl ether, CH3, CH2, OCH2, CH3, diethyl ether. What is the molecular formula? How many carbons are there? 4 carbons are there. Number of hydrogens 3, 3, 6, 7, 8, 9, 10. Hydrogens are 10, oxygen is 1. Okay, I'm writing the other ether here, that is CH3, CH2, CH2, OCH3. So therefore, for these two molecules, molecular formula is same. Functional group is also same, ether functional group. But nature of alkyl groups is different. On either sides, here we have ethyl group, but here we have propyl group, N-propyl group and methyl group. Nature of alkyl groups is different. So therefore, these two are called as metamers. So, organic molecules with same molecular formula and same functional group, but different in the nature of alkyl groups are called as metamers, and the phenomenon is said to be metamerism. This metamerism will be exhibited by only the molecules which contains polyvalent functional groups. This is the example for ethers. Next one is example for ketones. For example, you say CH3, CH2, CH2, C double bond O CH3. What is the IUPAC name of this molecule? How many carbons are there? 1, 2, 3, 4, 5 carbons are there. So therefore, this is said to be 2-pentanone. Pentane 2-one or 2-pentanone. And okay, so this side we have propyl group, on the other side we have methyl group. You change the nature of alkyl groups, then it will be converted into CH3, CH2, C double bond O, CH2 and CH3. So therefore on both sides we have ethyl groups. So same functional group, same molecular formula, but nature of alkyl groups on functional group is different. So therefore they said to be metamers. Metamerism is exhibited by ethers, metamerism is exhibited by ketones. Even esters are also exhibit metamerism. Simple example is that. CH3, C double bond O, OCH3, methyl acetate. What is the metamer of methyl acetate? It can be written HC double bond O, OC2H5. So here two methyl groups are there, valency is 2, but here nature of alkyl groups or hydrogen is different, therefore they say to be metamers. So ethers, esters and ketones will exhibit metamerism. Next one is metamerism is exhibited by secondary amines. For example, listen to me. CH3, CH2, CH2, NHCH3, N-methyl 1-propanamine. What is the metamer of this one? CH3, CH2, NHCH2, CH3. Diethylamine, and here it is said to be methyl N-propylamine. Nature of alkyl groups is different. So secondary amines will exhibit metamerism. Similarly, tertiary amines will exhibit metamerism, and the secondary amides and tertiary amines also exhibit metamerism. Thank you.